Qlik Cloud Data Integration can now transform data ingested by third-party tools and data shared within a data warehouse or lake. We looked at two sets of data pipeline needs. The first set is the requirements during data ingestion. Users wanted the ability to deselect and not replicate specified fact tables or other tables. They also wanted to eliminate or minimize full reloads when source schema changes or data environments fail. The second set of requirements was during data transformation. Users asked for model-driven data warehouse automation capabilities that accommodate late arriving dimensions. They wanted to delay merges of real-time data with historical data and align their cloud computing costs with analytics consumption needs. They also wanted to intelligently choose between materialized and non-materialized tables by balancing the number of users expected to access the tables or view and real-time expectations of the data to prevent unnecessary data churn. Here is a short demo of Qlik Cloud Data Integration's transformation capabilities that meet these needs for any data you have ingested or cleaned. Okay, so Qlik Data Integration can support many data movement and data transformation use cases, from simple onboarding to more sophisticated data modeling, and also automated data warehouse creation. In this example, I'm going to basically show you how to integrate data not only delivered by Qlik Cloud Data Integration, but also data that could be delivered to your target cloud platforms by other products, including our Qlik Replicate or solutions such as Talend Stitch. Now, to begin, I am going to simply onboard data and create a connection to one of many supported data sources. I'm going to use one that's already been created for me. In this case, it's a connection to an on-premise MySQL environment. It is important to note that with our gateway technology, we're able to connect directly and securely to your on-premise source systems without having to move data to our cloud. Now, as part of the onboarding process, we're going to automatically recognize changes in the data using change data capture, and also store a type 2 history of data in our storage layer. And as you can see, here we have just begun to build our data pipeline. Now we can also register data that already resides in our target platform. When I say register data, don't let that term confuse you. It's an industry term meaning that I can access the data that has already been landed to the target platform by another product and then use it for transformation purposes. This data can be landed by Qlik Replicate or by another solution such as Talend or Python or anything else that you've got that's loading data. Now here I'm going to select from our specific data schema, and I have the ability to incrementally process new records as data is coming from our other product, in this case Qlik Replicate, along with tracking type 2 history. Now how awesome is that? To save time, I've already built out the data pipeline by also registering data that was landed by Stitch into a target platform, in this case which happens to be Snowflake. At this point, we can start to leverage all the transformation capabilities available in Qlik Cloud Data Integration, basically to transform and curate our different data sets that I need for my analytics or whatever I need to use it for. Here we're going to begin by adding a transformation step into our data pipeline. We can add the additional source data, for example, our replicate landed data sets, and our Stitch landed data sets, and begin the curation process. Now, I'm going to start adding some custom SQL transformations to derive some data sets related to discontinued product sales. I can plug in any SQL here that operates within my target platform, allowing me to support a wide variety of transformation requirements. Now, in describing this table, it shows that the SQL is correct and I can review the output of the custom SQL that was defined. Custom SQL can be used to combine and transform data from multiple sources, whether loaded by Qlik Cloud Data Integration or registered data loaded by a third-party solution. Additionally, rules can be applied to data sets to adjust metadata and cleanse unknown values. For example, here I'm creating a rule to clean up unknown integer values, therefore transforming data without the need to perform custom SQL. Now, another step or task that a data steward can do is create a data model to define the relationships between the output of your transformation tasks and rules, leveraging both recommended relationships or custom-defined relationships through a drag-and-drop interface. This model will be used to help define a data mart task, which can be created inside Qlik Cloud Data Integration and provides automation around definition of the data mart, including ELT processing, denormalization, and incremental processing of your data into your data mart dimensions and fact tables. Here we're defining a number of dimensions to support Type 1 or Type 2 requirements. In defining the fact table, users can select the granularity of the fact table, along with explicit transaction dates used to pick up the appropriate Type 2 records as part of the automated ELT. The system will provide a set of recommended dimensions based off of the model that was generated in the prior step. Facts and dimensions can be curated further by adding columns and expressions to perform calculations and transformations within the data mart layer itself. At this point, I will just run my data pipeline and allow it to process the records as they come in from the source and registered platforms.